Alright, so in this video, I'm going to be solving the equation x to the power of 21 plus x to the power of 14 is equal to 36. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. What I'm first going to do is rewrite x to the power of 21 as x to the power of 7 times 3, and rewrite x to the power of 14 as x to the power of 7 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 7 times 3 is going to equal x to the power of 7 to the power of 3. And I have this plus x to the power of 7 to the power of 2 is equal to 36. Now from here, I can let x to the power of 7 equal to the variable y. So now if I substitute in y for x to the power of 7, I get y to the power of 3 plus y squared is equal to 36. And if I subtract 36 on both sides, I get y to the power of 3 plus y squared minus 36 is equal to 0. Now from here, I'm going to rewrite the 36 as negative 27 minus 9. And the reason I did this is because 27 I can rewrite as 3 to the power of 3, and 9 I can rewrite as 3 squared. And notice how I have a number to the power of 3 and that same number squared, and again 3 to the power of 3 and 3 squared. So now I'm going to switch the order and group the powers of 3's together and the powers of 2's together. Now from here, I can use two important properties. The first property is that if I have something from a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And now the second property is a squared minus b squared. This is equal to a plus b times a minus b. So y to the power of 3 minus 3 to the power of 3, we can rewrite as y minus 3 times y squared plus 3y plus 3 squared. And then now I have this plus y minus 3 times y plus 3 is equal to 0. Now from here, I have a common factor of y minus 3 on both terms. So if I factor out y minus 3, I get y minus 3 times y squared plus 3y plus 9 plus y plus 3. And this is equal to 0. And this turns into y minus 3 times y squared plus 4y plus 12 is equal to 0. All I did was add up all the like terms. Now, this gives me two equations. I get y minus 3 is equal to 0. And I also get y squared plus 4y plus 12 is equal to 0. So, for my first equation, y minus 3 equals 0, all I have to do is add 3 on both sides, and I get y equals 3. So this is my first solution of y. Now, for y squared plus 4y plus 12 is equal to 0, what I can do to solve this, because it's a quadratic equation, is use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 4, and c is 12. So I get y is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 12. And I have all this over 2a. Now this turns into y is equal to -4 plus or minus the square root of 16 minus 48 over 2. And this is equal to -4 plus or minus the square root of -32 over 2. And the square root of -32, I can rewrite that as the square root of 32 times the square root of -1. The square root of -1 is equal to I, the imaginary number I. So now I get -4 plus or minus the square root of 32, I over 2. Now the square root of 32 is the same thing as the square root of 4 times 8, which is equal to the square root of 4 times the square root of 8, which is equal to 2 root 8. So now I get y is equal to -4 plus or minus 2 root 8I over 2, which is equal to -2 plus or minus square root of I. So these are another two solutions of y. However, we're not done yet, because remember how we let back here, we let x to the power of 7 equal to y. So if x to the power of 7 is equal to y, then I get x to the power of 7 is equal to 3. And I also get x to the power of 7 is equal to this. However, you can't take the power of a number and make it equal to an imaginary number. So we cannot use these two values of y. And the only value of y that we can use is 3, because this is a whole number, not an imaginary number solution. So if x to the power of 7 is equal to 3, to solve this, I'm going to take the 7th root on both sides. So I get the 7th root of x to the power of 7 is equal to the 7th root of 3. The 7th root of the x to the power of 7 is x, so I get x is equal to 7th root of 3. Now to check, my equation was x to the power of 21 plus x to the power of 14 is equal to 36. And the 7th root of 3 is the same thing as 3 to the power of 1 over 7. Now 27 times 1 over 7 is 3, so I get 3 to the power of 3 plus 1 over 7 times 14 is 2. 3 to the power of 3 is 27, and 3 to the power of 2 is 9. So I get 36 is equal to 36. Alright, so in this video, I'm going to be solving the equation 3 to the power of x plus 3 to the power of x is equal to 12. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So let me first rewrite my equation down here so I have a little more solving space. So my equation is 3 to the power of x plus 3 to the power of x is equal to 12. And the first thing I'm going to do from here is factor out 3 to the power of x from my left-hand side. So I get 3 to the power of x times, well, 3 to the power of x divided by 3 to the power of x is 1. So 1 plus 1 is equal to 12. And 1 plus 1 is 2. So I get 3 to the power of x times 2 is equal to 12. And now I can divide both sides by 2. So then these two cancel out. And I get 3 to the power of x is equal to 6. Now from here, what I'm going to do is take the log on both sides. So I get log 3 to the power of x is equal to log 6. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 3 to the power of x, so I can move x to the front. So this turns into x times log 3 is equal to log 6. Now from here, I can divide both sides by log 3. So then these two cancel out, and I get x is equal to log 6 over log 3. Now, log 6 is the same thing as log of 3 times 2. And if I have something in the form log a times b, this is equal to log a plus log b. So log 3 times 2 turns into log 3 plus log 2, and I have this over log 3. So now this turns into log 3 over log 3 plus log 2 over log 3. So these two cancel out, and I get 1 plus log 2 over log 3. So this is my answer.